All right, we're continuing with our area discussion, and I think I don't know, they may ask for perimeter on here as well. I can't recall. Nah, it looks like they're just asking area. It doesn't look like they're asking perimeter. That really wouldn't be that big of a deal, as long as they gave you enough information. So what do I have right here? What's this thing called? Trapezoid, right. Remember, trapezoid has exactly one pair of parallel sides. Right, so this top one and this bottom one would be your parallel sides. The other two have to be non-parallel. Okay, in order to be a trapezoid, the other two cannot be parallel to each other. All right, I want you to see something before I just show you what the equation is for the area, or the formula, I guess, for the area of a trapezoid. This kind of looks a little bit familiar. Tell you what, let me make this a little smaller, because what I'm going to do here make it a lot easier. So watch, I'm going to just take this side right here and I'm going to extend it out. I've talked about this before. A trapezoid kind of has some similarities of something else. A triangle, exactly right. Because look, if I extend this like that, I didn't know how far I had to go with that. Look at that. I took that trapezoid and I just extended those two sides out. What did I get? I got a what? Got a triangle, didn't I? Okay, we learned yesterday what the area of a triangle is. Do you remember what the area of a triangle is? Yeah, it's base times height divided by 2. Alright, so that's a triangle. Alright, so that's the area of a triangle. But this thing that I originally had right there was not a triangle, it's a what? It's a trapezoid. So on a triangle, this was the base, right? And then the height would be what? From the top perpendicular to the base. Would you agree? All right. But this is not a, I'll tell you what, let me just undo all this stuff. Let's get back to where we were. There we go. And let's go back to the big one. There we go. I think that's good. So let's go back to this now. So you can kind of see, it's like a triangle, but what do we do to part of the triangle? It's like we whopped it off, right? We cut it off parallel to the base, so you can kind of picture this being a triangle. So a trapezoid, the way I like to remember the trapezoid formula is that it's kind of close. Jacob, you getting all this? Sit up. Thank you. It's kind of close to this. It's kind of close to a triangle formula. So the triangle formula is base times height divided by 2. But look at this. This doesn't just have, a trapezoid doesn't just have one base. It actually has two bases. Remember doing this? Remember we did a thing with a trapezoid where we found like the, what they call it, like the mid-segment or something like that. Do you remember that? And remember we added up the two bases and all that kind of stuff. Well, it has two bases. So this would be, we'll call it B1 for the one base, and this would be what? B2 for the other base. Everybody with me on that? So it actually has two bases. A triangle only had one base because these two sides came up to a point, didn't they? So they didn't have two bases. This has two different bases, but the formula is really close to the same thing. Let's just draw it right here. It'll be a little easier. Let's draw the height of this trapezoid. All right, that would be the height right there. So again, it's perpendicular to the base. It's actually perpendicular to both bases, isn't it? All right, because both bases are parallel to each other. We just talked when we went over those problems earlier that if you have a line that's parallel to perpendicular to one parallel line, it's going to be perpendicular to the other parallel line as well. All right, so it's going to be perpendicular to both of these. So this right here would be the height. So now, with all that said, let's kind of come up with a formula. Again, remember, it's very similar to the area of a triangle. What did I just do right there? Oh, there it goes. Okay. So here we go. This is the area of a trapezoid. So I'll just put A equals, starts off kind of the same, 1/2, right? Because remember, I put base times height divided by 2, but you could have said 1/2 times the base times the height. So this time, it's not just the base times the height. What do you think? It's not just one base, it's what? It's both of the bases. So what do I do to both of those bases, do you think? Add them up, exactly. So you go base 1 plus base 2 times what? Times the height. Now doesn't that look really close to the area of a triangle? The only thing different is the trapezoid has two bases, you just add the two bases together. That's it. That shouldn't be hard to remember, should it? So it's not like you got all this extra stuff to memorize. You just remember the area of a triangle. The area of a trapezoid is really, really close to it, except you just have to remember. Remember that little thing what I did? You know, I turned that trapezoid into a triangle, and you say, okay, yeah, trapezoid even starts with T, doesn't it? All right? TR even, okay, it's that close. So a trapezoid's really close to triangle, so I'm thinking, okay, area of a triangle is 1/2 the base times the height. Trapezoid, the only thing real different is it's got 2 bases. So I just go 1/2, both bases added together, times the height. Okay, you could write it a different way. It's not really much different, but you could go what? B1 plus B2 times the height, what? Over 2. Whatever way you're more comfortable with, all right? You could write it. They mean exactly the same thing, all right? It's just 2 slightly different versions of writing it, all right? So either one of those ways, you could write it just like that. Everybody good with that? All right. Let's do a little example with this, and we're going to go a little bit beyond just the area of one trapezoid. All right. So this is like the first time we're going to actually combine a couple different figures together to find the area of this. So it's not just one parallelogram. It's not just one triangle or one trapezoid. It's actually a couple things combined. And you're going to be doing a lot of that stuff when you take the SAT. They'll be doing a lot of that kind of stuff. They won't just ask for the area of a rectangle. They'll stick a rectangle with a triangle on top of it with a semicircle next to it or something like that. And you got to find the area of that whole entire thing. All right, so it's not just as easy as just finding the area of just one particular figure. So let's do an example real quick. All right, here's the figure, and let's put some numbers in here. Let's see. This is 4. Actually, hang on just a sec. All right, we're on the right track. This right here is 10. This is 8.5, this slanted one right here. And that's all they give you. Yep. They do tell you, though, that this is a right angle and this is a right angle. So there you go. And you want to find the area of this figure right here. Well, let's see what color do I want to go to. Let's go to this color. Is that necessarily just one of the figures that we've talked about right here? No, not necessarily. You could break the thing down, couldn't you? Okay. I'm looking at this. Well, you don't even have to go 2 triangles, do you? Yeah. Okay. Well, do you necessarily know it's a square? Yeah, we'll call it a rectangle. Do you know? I mean, it kind of looks like a square, but just because it looks like a square, does it mean it's a square? Because from here to here is 10, isn't it? All right. So, what do you think? All right, let's take a look. So what's that 10? Let's make this a little bit easier to see. So the 10 goes from here all the way to here. Do you agree? So that and that is 10. All right. And let's make this another color. So what are some other things we know just by looking at it? I made this parallel to this, so what should this side right here be? This should be 4 as well. So what do you think we can... I mean, just by looking at this, can we make an assumption that that's a square and that's 4 as well? We can?
Yeah.
I don't think we can. Yeah, because we don't... just because this is 10, does that mean this is 4 right here? We don't know. All right? Maybe. You're right. Maybe. But that's the key. Maybe. We don't know for sure. What can we find, though? I could find this distance from here to here, couldn't I? Okay. We'll call that. Yeah, exactly. Pythagorean Theorem. So let's do that. So I've got x squared plus 4 squared equals 8.5 squared. All right. And you know what we're going to do? We're going to subtract a 4 squared, right? So it's 8.5 squared. 8.5 squared minus 4 squared. Okay, equals, and then you can take the square root of that. So the square root of my answer, and that's 7.5. So x right here is 7.5. Is this 4 then? No, what is this? What's this little bit from here to here? It's 2.5. It's 10 minus 7.5, right? Which is actually 2.5. So that's 2.5 right there. Does that make sense? Alright, so what are we going to do? Let's find this. It's not a square, is it? It's kind of drawn so it looks like one, but you just can't go by that. Make sure you understand that. It's a rectangle, so it's just base times height. So it's whatever that is. Let's see. Twice that is 5, and twice that is 10. Is that 10? Yeah, it's 10, isn't it? So the area of this whole thing right there is 10. Did I do that right?
No. Isn't it? It's 2.
2.5 times 4.
That's for
This is just, I'm just finding this rectangle. I'm just finding this rectangle right here. Okay, 2.5 times 4 is 10. I was correct. Alright. What about this one right here? How do we find this? Base times height divided by 2, isn't it? So it's base times height divided by 2, which is basically, watch, that cancels that out. Twice that. What's twice that? It's 15, isn't it? So that's 15. So what's the whole entire thing?
25.
That's it. You just add the two things together, and so the total area, I'll put total, area total is equal to 25. Whatever it's in. Let's say it's in inches. I don't even know what it's in. So it's inches squared. And there you go. Does that make sense? I know that had nothing to do with the parallelogram. Or not, I mean, trapezoid. But I don't know, is that a trapezoid? Parallel sides. This is not parallel. Well, yeah, I guess this could still be considered a trapezoid, couldn't it? Yeah. Let's do this. I don't know why I didn't even think of looking at this as a trapezoid. Yeah, because this is a trapezoid because that and that are parallel to each other, right? So what did I say again? That was 10. And what was this? Yeah, I still had to figure that out, didn't I? Okay, so I still had to figure that out, which was what, 2.5, wasn't it? And I don't even need that, do I? I don't need that 8.5 to find that. Well, I needed it. Well, I did need it. So I did need to do all that stuff that I did. Okay? But I could have done this. I could have just said, well, what's the area of a trapezoid? I'll put trap right here. Well, it's 1/2, what? Both bases added up times the height. What's both bases added up? Well, it's 10. 10 plus what? Because that's one base. What was the other base? This side right here, which is 2.5. That's right. Everybody see that? Because it's the same as this one right here. So that's 2.5 times the height. What would the height be on this? It's 4, because this is, right? The height and the base are perpendicular to each other, so that would be 4. So let's do this. Half of 4 is what? 2. And this is what? 12.5. So if I take 12.5 times 2, that's 25, isn't it? Yeah, so it works out the same way. So you could use the trapezoid formula, or you could just split them in two, find both of them, add them together, and you could get it as well. Make sense? Okay, let's move on. Alright, let's look at these two things. This is the last thing we're going to do. There are two different. Now this kind of looks like a parallelogram, doesn't it, right here? But it's a little more specific. This, 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 and this are equal to each other. What name do we give that? A rhombus. That's right. If I have 4 sides and all 4 sides are equal to each other, we call this a rhombus. What about this dealie right here? It's a kite. Remember the kite? Okay. So we have an area. And the nice thing about this, on both of these figures right here, the area of both of them is exactly the same formula. So that's kind of nice, isn't it? So we take 2, we make it 1. So the area, this is area of a kite and a rhombus have the same exact formula, which is kind of cool. So here it is. The area is equal to 1/2. All right, there's our half again. Now watch, this is a little different than what we've done before. We're not using base and height this time. We're actually using the diagonals. So I'm going to take one diagonal and multiply it by the other diagonal. So if you come up here, let's ungroup this. And we'll make these different colors. We'll make this one this red color. I don't know, can you see that? We'll make it a little brighter. There we go. And then we'll make this yellow. Those are your two diagonals right there. Everybody see that on a kite? So if you know those two lengths, what do you do to those two lengths? Multiply them together. Don't add them. You multiply them together and then take what? Half of it. Okay, divided by 2. You could put it over 2 if you wanted to instead of 1/2 in front. But you take those 2 and you divide it by 2. And where's my diagonals here? Well, that would be one diagonal. Agreed? And then this would be another diagonal right here. So that's pretty easy. So you take the two diagonals, you multiply them together, take half of that, and then you've got the area of that whole entire kite, or in this case, the area of that whole entire rhombus. Right? Because there are times, because you're like, well, a rhombus is the same as a parallelogram, why can't I just go base times height? But what if they don't give you enough information to figure out what the base and the height are, but they do give you the diagonals, right? Then it makes it a lot easier knowing this formula right here. Now, it's only true if all four sides are equal to each other. You understand that? Okay, it's not true about every single parallelogram. It's only true about when the four sides are equal, meaning it's a rhombus. We okay with that? I don't think we have to do an example with that, do we? All right, it's pretty straightforward. Just take the two diagonals, multiply them together, divide them by 2, and you're good to go. Yes?
Like, for the diagonals, would they ever give you, like, if I diagonal down, like, have to do that?
Yeah, absolutely. They could. Yep. They're not always going to give you that whole entire diagonal and this whole entire diagonal right here. Absolutely.
They give you one and then they put like a dash.
Yep, there's all kinds of crazy things they could do with this, okay? But that's where the fun lies, right? Trying to figure out how to find the missing parts and all that kind of stuff. Absolutely. That's what I think anyway. I mean, wouldn't it be boring just to have a whole bunch of problems where they just gave you both of these things, you just plug it in and get an answer? I mean, it wouldn't take any thought, wouldn't take any imagination whatsoever. I think that would be pretty boring, to tell you the truth. I bet you there's people in here that agree with me. You're just, peer pressure just says that you don't want to say anything. But I'll stand up and say, I think it is a little more interesting. Like I said, that,
It takes longer.
well, yeah, it takes longer, but who cares? Who cares if it takes longer? Like, look, I was challenged a little bit because that kid asked me about those SAT problems. He had done a ton of SAT practice problems, but he whittled it down to like 15 that he couldn't do. So there were probably 15 of the harder problems. And some of the problems were a pretty decent challenge to me, and I had to sit there and think about it, but it was kind of fun. I was like, yeah, this is kind of cool. And I finally got the answer, you know, and I was all excited about it and everything. And there's nothing wrong with that. Go ahead and laugh. You can snicker if you want. I don't care. But it was fun. And I think, listen to me, there's a lot more to fun than just riding roller coasters or playing a video game or playing ping pong or something like that, okay? There's a lot more. Intellectually, you can have some fun with some stuff. Have a little challenge, okay, work hard at it, and then you come up with the right answer. To me, that's pretty cool. That's pretty fun. All right? I didn't say that. Did I ever say I would rather do that? No. I said, but you can find some joy and you can find some fulfillment and some fun in doing some math problems. If you have a little bit of a challenge and you actually work it out, come up with the right answer, I think that's pretty fulfilling. I think it's a pretty fun thing to do. So there you go. There's your problems, 8 to 21, section 11-2.